Welcome to our new channel, Next Level Tutorial. Today, we're diving into the world of free body diagrams. If you've ever wondered how to draw the perfect free body diagram, you're in the right place. We'll cover all the key steps and important details you need to pay attention to, ensuring you can maximize your chances of scoring all the points when you encounter these questions in your exams. Let's get started and bring your skills to next level. We'll break down the process into a few key steps, making it easy to understand and draw a free body diagram. The first step in creating a free body diagram is to draw the environment. The exam questions use Susely states what the scenes look like. It sets the stage for everything that follows, so it's crucial to get it right. Our environment can be anything from a flat floor to obstacles or a wall. Make sure it's well-defined and clear. Remember, a well-drawn environment makes the rest of the process much smoother. Next, we'll draw the object within this environment. Our object can be as simple as a box or a circle, or a vehicle in a simple shape. The key here is to make sure it's clear and easy to identify. This clarity will be crucial when we start adding forces in the next step. Now comes the exciting part, identifying the forces acting on your object. There are four main types of forces we need to consider: weight, applied force, friction, and normal reaction. These are denoted by W, A, F, and N, respectively. The first type of force is weight. Weight is a type of force pulls objects towards the center of the Earth, or any other planet for that matter. This force is always present, unless the question states precisely the scene is in the vacuum of space where gravity doesn't exist. Now, let us draw the arrow that represents the weight. The arrow always starts from the center of gravity and pointing downward to the planet's center. Do remember, we always want to label the arrow right after we draw it. Some students have the habit to draw all arrows before labeling them in one go. However, that is not recommended, as we may miss some labels in a complicated diagram. Labeling it now can eliminate the chance of missing labels and lose points in the exam. Alright, let's look at the second type of force, applied force. This is an external force exerted by another system, like a person pushing an object or the tension in a rope. To tackle questions about applied force, we need to read the question carefully and consider a few key points. First, does an applied force exist? If so, where is it applied and in what direction? There are only two possibilities. The force is either a push or a pull. Remember, multiple applied forces can exist simultaneously, so it's crucial to read the question carefully to ensure all forces described are included. Now, let's practice drawing an applied force in an example scenario. Imagine a person pushing an object from the left. To represent the applied force, we need to draw an arrow. In this case, the force is applied from the left side of the system, pushing the object to the right. So, we draw and label an arrow from left to right. Make sure to label the force immediately. This time, we'll label it as F subscript A. Note that it's also acceptable to label the applied force with other characters based on the scenario, like T for tension or F subscript push for a pushing force. Alright, let's look at the third type of force, friction, also known as frictional force. There are a few key points to consider. First, does it exist? To determine this, we need to look for contact between the object and a rough surface, which is crucial. There has to be a rough surface to create friction. This is usually stated in the exam question. The second element to consider is the motion or force component that is parallel to the surface. This is important because frictional force is a reaction to motion or a force component parallel to the surface. If there's no movement or no force trying to push the object along the surface, there is no friction. Frictional force exists in the contact area between the object and the rough surface. Remember, it always acts in the direction opposite to the motion or force component. In this case, since there is a force to push the object from left to right, the frictional force will oppose this, acting from right to left. Also, frictional force is always in a direction parallel to the rough surface. We will draw the arrow at the contact point between the object and rough surface. Don't forget to label it immediately with the letter F subscript lowercase f. The final type of force we'll discuss is the normal force, also known as the normal reaction. This force is exerted by an immovable object, like a wall, to prevent other objects from passing through it. Again, we need to consider the following. First, Is there an immovable obstacle or wall that blocks motion or acceleration? If so, the normal reaction is always exerted from the immovable surface to the object in a direction that is perpendicular to and away from the surface. To illustrate the normal reaction, draw an arrow starting at the contact point between the object and the surface, pointing perpendicularly away from the surface. Don't forget to label this arrow with the letter N right away. If we have stick to the video and follow through all the procedures, we shall see a complete free body diagram where all the forces that act on the object are being drawn and labeled clearly. Now, let's summarize what we've covered today to answer a free body diagram drawing question in an exam. First, read the question carefully, sentence by sentence, and understand every word. Next, draw the environment to set the scene for the free body diagram. Use simple shapes to represent the object. Then, consider each type of force in sequence. Weight, W, applied force, A, friction, F, and normal force, N. For each force, ask ourselves, does this force exist? If so, where does it come from and in which direction does it act? Once we've considered these questions, start drawing the arrows for each force. Make sure to label each arrow immediately. After you've drawn all 4 types of forces, you should have a complete free body diagram. This will help you score well in your exam. Happy drawing free body diagram!